Good morning. For today's lesson, we are going to be looking at molar conversions. In today's work, you will be using three different molar conversions. The mole is a central unit in chemistry. It is equal to 6.02 times 10 to the 23rd particles. Particles can be listed as formula units, or molecules, or atoms. 1 mole is equal to the molar mass of a given compound, which we worked on in our last lesson. Also, 1 mole of a gas is going to take up a volume of 22.4 liters at standard conditions, which we call STP. Using the conversion factors, we can convert between mass, volume, particles, and moles. You will notice that the mole is the central unit among the four. We cannot convert, for instance, directly between mass and particles without first passing through the unit of the mole. Whenever we are leaving the unit of the mole, we are going to be multiplying by our conversion factor. So when we leave and we want to go to volume, we will multiply by 22.4 liters. If we're trying to go from moles to mass, we will multiply by the molar mass. If we are trying to go moles to particles, we will multiply by 6.02 times 10 to 23rd. The opposite is true if we want to go from an outer unit to the mole. We will always be dividing by that conversion factor. At this point, you may wish to pause the video and write down the questions from the sheet that I sent you in bold. I will be going through the bolded questions as example problems. We are going to start with our first problem where we have 1.20 times 10 to the 25th atoms of phosphorus. To convert to moles, we are going to make a conversion bridge. And because we are leaving the unit of atoms, we are going to be dividing by 6.02 times 10 to the 23rd. We will then be multiplying by 1 mole to get the unit that we want. That should get us an answer of 19.93 mole. Next, we will be finding the number of grams in 7.26 moles of H2SO4. To do this, we are going to need to have the molar mass of our sulfuric acid. We are going to, in this case, put 1 mole on bottom, and on top we are going to put the molar mass. Pause now if you would like to solve for the molar mass yourself. The molar mass is 130.14 grams per mole. We are now going to multiply across the top, and our units will cancel top to bottom. This will give us a mass of 944 grams. For our last conversion, we are going to be converting between 2 units. We are going to be starting with 14 grams of nitrogen, but the problem does not want us to end in moles. The problem wants to know what that volume would be at STP. To do this, we first need to convert to the mole. We start with the molar mass of nitrogen, which is a little tricky because it is diatomic. So we are going to have 28.00 grams on bottom, and on the top we are going to have 1 mole. We are then going to extend our conversion bridge. We are going to have 1 mole on bottom, which will cancel the 1 mole on top. And we are going to have our volume conversion factor, which is 22.4 liters. Now, if we multiply everything on top and divide by everything on bottom, that is going to leave us with an answer of 11.2 liters. If you have any questions, please feel free to email. Also, check the beginning of the video to see if you can figure out the puzzle I left you. Have a good day.